All right, we're back. We're in Calc AB Notes 2, talking about the chain rule. We're in the middle of a problem where we have the graph of f and the graph of g, and we're trying to find the slopes of some compositions and some weirdly defined functions, but let's continue. I do like the idea of letting this equal something because it's easier to talk about that way. So we got this. So h prime of x, the derivative of f of something is f prime of that thing. The derivative of g of something is g prime of that thing. The derivative of x squared is 2x. And that's how you know you're done with the chain rule, is when you finally get to something where you're just like, boom, I know the derivative, I'm going to write it down and be done. So h prime of 1.5, this seems like it's going to be annoying. We'll see, is g of 1.5 squared is 2.25. So that's fun. G prime of 2.25, and then 1.5 times 2, should really make that decimal clear, is 3. So let's see what G of 2.25 is. G of 2. All right, G of 2.25. So 2.25 is probably like here. All right, I need to find. So, I mean, that's definitely somewhere between -1 and 0. I know that it's between -1 and 0. So now I need to find f prime of a number between -1 and 0. What's really nice about that is that for every number between -1 and 0, like here, f prime is the same. So I don't actually need to find the exact value because I can find f prime of the value without knowing the exact value. So f prime of a number between -1 and 0, which is definitely what g of 2.25 is. So the slope of f at those values is going to be up 1 over 3. So that's 1/3. And I'm like, am I breaking my own rule? Like, I don't know, kind of. But also, like, who wants to not break that rule? I need g prime of 2.25, which is, that's okay to find. That's up 2 over 1, so 2. So 2. And then we're going to multiply by 3. So we actually just overall get 2. So I'm going to highlight this a little so that you can see that, like, all of this, we were able to get 1/3. And then this we saw from the graph was 2. And then 3 is 3. So that's a thing you can do. You don't necessarily need to find it. Like, I didn't need to find g of 2.25 because it's very clear that g of 2.25 is somewhere between -1 and 0. And then if you go between -1 and 0, the slope is always the same. So I didn't need to really find it, which is it's a power move is what that is. Let's define this as h of, so my inclination, if I only see f of x, is to define the function as g of x, but g of x is involved in this problem, so you do not want to do that. So I'm going to call h of x and say I'll follow the size or whatever of the brackets and parentheses. So h prime of x. So something squared is 2 times that thing to the first power. The derivative of f of something is f prime of that thing. The derivative of x over 3 is 1/3. All right, so now at -3, h prime of -3, it's going to be 2. F of -3 divided by 3 is -1. F prime also of -1, and then 1/3. All right, so I need f and f prime of -1. So let's find that. All right, f of -1, super annoying. So there's multiple ways that I can figure this out. Like, I know that if I start here, I'm at 2, and then I know that the slope of the line as I go to the right is 1/3. So if I only go over 1, I go up 1/3. So I definitely know that this point, f of -1, should be 2 plus 1/3, which is 7/3. And it like feels right. The alternative, I could write the equation of that line segment and plug in -1, which is not a bad thing to do, right? That would be, it's essentially the same idea, actually. It would be y, so point slope, y minus 2 equals 1/3, and then x, what is it, plus 2. So then y of -1 is going to be 2 plus 1/3 times 1. And there you go. Same thing, 7/3. And then the slope we know is 1/3 because we used it. So 7/3 and 1/3. Where are you? Here we go. So this is going to be 2. We got 7/3. We got 1/3. Then there's another 1/3. A lot of thirds here. So that's 7 times 2 is 14 over 3 cubed is 27. So I think that's h prime of -3. These are good problems. You got to get used to like looking at a graph and pulling values, especially pulling values of derivatives from line segments. It's just the slope, but like that's not the most natural thing in the world when you first start doing this. All right, let's see. Looks like we got a product here. So I'm going to make it h of x, and then I'm going to product rule this. So we're using product rule because it's a product, but then each of the derivatives of the first and the second requires a chain rule. So it's everything. All right, h prime of x. First is f of 2x. Derivative of the second is going to be g prime of 4x times the derivative of 4x is 4, plus second, which is g of 4x, times the derivative f sum f prime of 2x times the derivative of 2x is 2. All right, so then we plug in, we find h prime of 1. So f of 2, g prime of 4 times 4, plus g of 4, f prime of 2, and then times 2. And you kind of just hope that something doesn't exist. Let's go find f of 2. F of 2, super annoying. So f of 2 got to actually work out, right? So if you start up here at 3, and then you go over 1, what is the slope? So it's down 2 over 3, -2/3. So if you only go over 1, you go down 2/3. So if you were at 3, so it's going to be 3 minus 2/3, 9, so 7/3, which is exactly the same as f of -1. That's kind of interesting. Alternatively, we could write the equation, right? So the equation would have been y minus 3 equals -2/3 x minus 1. And then we would plug in 2, and you end up with 3 minus 2/3. You get 7/3 no matter how you do it. So that's 7/3. Okay, now we need g prime of 4. So g prime of 4. G prime of 4 is good to find because line segments have the best slopes. Up 1 over 3, so that's going to be 1/3. So 1/3, and then times 4, plus g of 4. Should have gotten it while I was there. G of 4, if it's like anything else, will be annoying. Yep, so it's, we're at 1 here, and we go over 1, so we go up 1/3. So 1 plus 1/3 is 4/3. That's where we're going to end up. So 4/3. Okay. We need f prime of 2, which again, we probably should have gotten while we were there. F prime of 2 is, we're looking at, what are we looking at, and how can I highlight it so it works? We're looking at this, right? So it's down 2 over 3, -2/3. So close, -2/3. And then we got to multiply by 2. Okay, so what on earth? So 28 over 9 minus 16 over 9, I guess. So equals. I owe the math universe a billion equal signs. I do not write equal signs. I don't know. I feel like if I'm moving vertically, like you should know that it's equal, but that's not true. So 12 over 9. So 4/3. I think that h prime of 1 is 4/3. All right, and let's take a look at this last one. So again, we're going to define as h of x. This pi over 2, I'm not worried about because I see sine of 2x, and sine of 2 times pi over 2 is the sine of pi. The sine of pi is 0. So I think we're in good shape, but you know, we're still worried about it. I'm not concerned, you know, like I see it. This is a lot of a lot of composed functions here. Like if you were to write this out, you would have y equals u cubed, u equals g of w, w is equal to sine of v, and v is equal to 2x. So look at that. We're going to do dy du, du dw, dw dv, dv dx, which will leave us with dy dx when we're done. So let's try to implement that. So h prime of x, probably going to be really long. So it's 3 times the thing to the second times the derivative of the thing, which is g prime of a new thing, times the derivative of the thing. The derivative of sine or something is cosine of the thing, times the derivative of the thing. The derivative of 2x is 2. Whew. So you can see it though, 4 functions, 4 derivatives. That's all you get. Now we're going to find h prime of pi over 2, which, good grief, is going to be 3 g of the sine of so the sine, where am I going to write this? I'll write it down here. The sine of 2 times pi over 2 is the sine of pi, which is 0. So really this becomes g of 0 squared times g prime of 0 times cosine of pi, not 0, cosine of pi, which is -1, and times 2. All right, g of 0, g prime of 0. I'm actually going to be disappointed if either of those don't exist. No, they're good. They're just annoying. All right, so 0 here. All right, so I'm at -2, and if I go over 1, I should go up 1/3. So -2 plus 1/3, -6/3, -5/3. Or we write the equation and we sub in. Doesn't make a difference. I like to use the slope when I can. Basically in calculus, I like to try to use the slope as much as I can. And then we also are going to need the slope while we're speaking of it, which is definitely up 1/3. So I don't know if I'm going to remember that. So this is going to be h prime of pi over 3 is 3 -5/3 squared times 1/3 times -1 times 2. All right, let me just make sure I got those right. -5/3 and +1/3. Good, I think. So this will be 3, 25 over 9, 1/3. The 3 and the 1/3 are going to cancel. And let's say my -2. So the 3 and the, so negative, I think we get -50 over 9. It's weird, but you know, why wouldn't it be? So that's h prime of pi over 3, which is not pi over 3. I don't know why I'm writing that. It's pi over 2, which I used all the way through. So I don't know. I just started saying things are over 3 at some point and, you know, kind of went with it. All right. Whew. That's that, I think. All right. So I'm going to obviously cut this video here. Who knows how long this video is? Probably kind of long. And I will be back in the next video to start the next page. So I will see you there.